Hello, QCOM. My name is Antonio Ojea. I work at Google.
And I'm Lionel from Red Hat.
We have been working at Kubernetes networking for a long time, maybe a long time. Well, we are here because we want to share a story. The story of how this community was evolving Kubernetes networking. I've been working in Kubernetes for a long time, as I said, and I can say that Kubernetes is no longer only a project. Kubernetes is a standard. Kubernetes is the foundation of the cloud-native ecosystem. And the other important thing is that Kubernetes is also evolving. Kubernetes is adapting for these new workloads that are coming from AI, telco, high-performance computing. These workloads are different. They require new hardware, accelerators, CPUs, GPUs, synchronization with the network data center. And the standard Kubernetes networking model was not prepared for this. So if we dive into these new workloads, we can start to see some patterns. We see that these large VLLM training models that need to execute complex operations and synchronize GPUs with high, ultra-low level latency. If you have just milliseconds of latency, it causes a big penalty on the performance of the training job. In the other side, in the telco space, you need rock-solid applications. You need multiple interfaces for redundancy. You need NUMA, NIC, and CPU alignment for line rate packet processing. And as you can see, there is a common pattern. All of them have a common problem. They need direct access for hardware. And this needs is reshaping how we think about Kubernetes today, and it's evolving Kubernetes networking.
So how do we solve this? Well, this evolution was not a single project. This was the result of an effort, a collaboration between multiple companies and communities, and also the convergence of many ideas and experiments over several years. This is where the community-driven part is so critical. When facing the limits, the community always finds creative solutions. We saw this everywhere, as every community was creating their own solution based on custom annotation and CRDs. These solutions are brilliant. They are solving immediate and real problems for the users. But they are also non-portable. They create fragmentation, so what works on one Kubernetes distribution would not necessarily work on another. And we were starting to lose the core promise of Kubernetes, which is to have a consistent and portable API. The innovation coming first is a familiar pattern in Kubernetes. The standardization follows once the problem space becomes clear. And the standardization here didn't happen overnight. It has been a decade-long conversation starting back in 2015 with the CNI spec itself. Later, in 2017, in Kubernetes, device plugin appeared as a stable feature in Kubernetes. Following that, the same year, the Network Plumbing Working Group has been formed to solve new challenges in Kubernetes around networking and network resources. From around 2018 to 2022, we could observe the evolution of the network leading project that we all use now. And since 2022, the status quo is being challenged by proposing to absorb the problem directly in Kubernetes. Some attempt has already been made, for example, the multi-network cap or the Kubernetes network interface K9 proposal. And each step was a lesson. Each project brought us closer until the community finally converged on Dynamic Resource Allocation, DRA. And it is what finally enables the concept we are talking about today, the Kubernetes network driver. At the core of this evolution, we have Dynamic Resource Allocation, DRA. DRA gives us a common language to describe and manage whether it's a GPU, any resource, whether it's GPU, SmartNIC, or secondary networks, or any kind of resources you can imagine. It is declarative, it is extensible, and it is built for the real world. So no more fragmentation. Just a way to say, a standard way to say, my pod needs these resources with these guarantees, give me the optimal resource usage, and then Kubernetes will do what it is built for, orchestrate and satisfy these requests. Built on top of it, KND, Kubernetes Network Driver, has explained, emerging ecosystems are very sensitive and have strict requirements. So Antonio here did research and evaluation on this domain using the Kubernetes Network Driver model. And it has been demonstrated that a declarative approach where users express exactly what resource and guarantees their pod need, deliver higher performance, predictable behavior, and a better utilization for the hardware. So let's see this in action now. I'm going to show you how a pod can declaratively request a specific network resource via DRA. This demo runs a simple DRA driver that has been created for this keynote. It's just 500 lines of code, and its goal is to expose and allocate resources via DRA, also to act as a container runtime plugin via NRI, Node Resource Interface, to configure the pod by moving interface to the pod. So this demo is a very simple demo with the basic features that DRA provide. But DRA, in reality, provides way more things. This is just a demo again. So what I'm going to show you is what I have in my cluster. I have my Kubernetes network driver that is running on each node. This Kubernetes network driver are exposing via resource slice the resources that are available on each node. So for each node, we have a resource slice that exposes the resources. So in our case, it's just dummy interfaces that we have. In the first worker node, we have two dummy interfaces. One has the particularity that it has an NTU of 9,000. And then if we check another node, we will see that the other node has only one interface, which is similar as the other nodes. Just it missed the dummy 0 interface, which has the NTU of 9,000. So the demo shows that we have a pod that we will deploy, and it requests via another object that DRA provides, the resource claim. So in this object, we are declaratively express what we want for this specific pod. So what we want here is to configure an interface that has an MTU of higher or equal to 9,000. So let's deploy this pod now. So the pod is being created now. And what is happening in Kubernetes is that the pod is being scheduled based on the resources that it has requested. So the pod is now running now, and it is running on the node which has the resources that are available for satisfying those requests. So again, it was requesting via the dummy interface that has an MTU higher or equal to 9,000. So we can analyze this via the resource claim status. So we have a resource claim here that has been allocated. So if we look into it in the status, we will see that the resource has been allocated from the dummy 0 on the first kind worker. And if we look into the pod itself, then we'll see that the demo 0 has been configured in the pod. Again, this is just a simple example, and DRA is capable of way more things. And that was the demo.
So I really love the demo, and one of the more important things that I love from the demo is the user experience. So you don't have more annotations, it's declarative, and it works perfectly. But we believe that for new APIs, for new Kubernetes network driver model, we need to grow an ecosystem. And we at Google were working in a Kubernetes network driver. We call it DRA Net. And this Kubernetes network driver was designed to solve the AI/ML networking problem in Kubernetes. And we are happy to announce today that we are going to donate to the CNCF, to the Kubernetes organization. It's going to be now a true project under the Kubernetes umbrella.
Slide. Next slide.
DRA Net is, as I said, it's a driver, Kubernetes network driver, and it's able to coordinate with other drivers that handles accelerators to achieve optimal performance. And can we please, let's do it today, now, live in a stage. Let's donate it if we can switch to Lionel laptop. Let's do the donation here, live.
Should I press it?
Please, go. We expect to build on this, right? Because, as we say, this is about composition. We have different hardware, we have different drivers, and they need to work together. As you see in the photos, this is a community-driven development, right? What we want from all of you is you have a pod, you have a workload, and you want to connect your high-speed NIC with your high-speed accelerator and with your super high-speed performance storage. That's the model that we are fostering, a model of collaboration. And this is not in the future, this is in the present. We are already working on this. You can see that we already have some drivers that are implementing different functionalities. We have DRA Net for AI/ML. We have CNI DRA driver for migration from the legacy stack. We have DRA for CPU to align NICs and NICs with NUMA node and CPU topology. So all of you are welcome to collaborate in this journey. You can join SIG Network communities meetings to give your feedback, propose your ideas, or if you are more interested in DRA and the internals of DRA, you can join the the device management working group. So this is all. We are building the future. Please help us to build it the best for Kubernetes and for all the community. Thank you.
Thank you.